So I'm going to go ahead and draw us in a t-table. Hopefully you guys can see me drawing two. We're picking some x's to find our y's, and some good choices for us to use would be something like -2, -1, 0, 1, and 2. Not law, just super common, easy to use, gives us a good view of the center. It's a good habit to be in. Those are great options to choose. So when we put those into our 3 to the x, that's when we're going to get something like 1/9, because 3 to the -2 gives us not only our reflected or our reciprocal, but it also gives us that squared. So 3 to the power of -2 is 1/3 squared. So we get that 1/9, and 3 to the -1 gives us our 1/3. 3 to the 0, anything raised to a 0 power is going to be 1. 3 to the first is 3, and 3 squared is 9. So those values should be hopefully things we know. We also know that on our parent functions, we are going to have an asymptote on our x-axis. The equation for that is our y equals 0. So that just means I am not going to cross that x-axis. We are not going to have any roots. So we just have to like get close to it. So when we plot up our points on my little makeshift graph over here, we're going to have our -2, 1/9. So we're really, really close to that axis here. My -1, we're at 1/3. So we're still pretty darn close to that axis. And at 0, 1, 1, 3. So 1, 2, 3 up here. And 2, 9. Which I know the one on the bell work paper doesn't go up to 9. I honestly don't know if mine does here or not. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, look, it does. Right at the top edge. Okay, I know the one on the bell work paper does not go up that high. And that's okay. Just draw a little arrow up there. You can just put a boop arrow. Because this is going to come down like this. And just hug our axis like this. So on a lot of these questions, we're going to ask you the domain, the range, and the equation of the asymptote. Where's the letter down here? So our domain, and this is true for all of our exponential functions, all of our exponentials are going to have a domain that goes from -infinity to +infinity. We're using all real numbers. Our range on this one, we're looking at our smallest with the y values up to our biggest. That's going to go from 0, it's always going to be based off our asymptote, up to infinity. And then our asymptote, this little wall that we have that we can't cross, that equation is this guy right here. So the equation for our asymptote is our y equals 0. Okay. Any questions on that one? You're welcome to unmute and ask, or you can go into the chat. There's a chat. I don't know what it looks like on your end. Mine's at the top of my page. That is where the button for the chat is. So. Oh, it's going to do some weird jumps on us there. Ah, sorry. I can put that back up. Oh, it's going to be super grumpy about it, and it's going to lock me into 8 o'clock in the morning, but you know what it is. Any questions on the bell work part? Okay, because what we're going to do, instead of me doing any kind of like notes or anything, what I'm going to have you do is I'm going to have you grab out the homework that you picked up yesterday. So grab out the 7-4 homework. It's actually the 7-3 homework. It just says, you know, Module 7 homework 4 at the top because I wasn't going to reprint when I noticed it was numbered wrong. Technically, I think it's section 4 in the book, but it's the third homework we have in 7. It's the one that has like the big list on the front where it talks about our transformations. And we'll talk through those here in just a second. But what we're going to do is I want you to look at the back and look at the graphs. We're going to do number 5, A. Oh no, we're gonna do number 5. I was looking how they were numbered. Okay, so the one up on the screen right now is number 5. That way, we don't have to worry about not having graphs in our workbooks or taking notes, things like that. Gives us a little benefit, easy peasy on the homework. Okay? So that way we don't have to kind of deal with that mess. So we're gonna do number 5, and we've actually already done part of it. The bell work problem that we just did, that actually is the parent function for question number 5. And the reason we can tell that, not only do we tell you that in part A, but also the base of our exponential function here, this guy, that's our parent function. The thing that has the exponent, my 3 to the x. So our parent function here, oop, my screen's gonna do some weird on us. There we go. That table that we just made in the bell work is exactly what we want to have as our parent table, where we had our -2, -1, 0, 1, and 2, and our y's were our 1/9, 1/3, 1, 3, and 9. So whenever I'm graphing the parent function, got it marked. All right, so whenever we're graphing that parent function, I tend to do it in a lighter color, or I'll do it in like very light pencil. So I'm going to do it in a super light blue up here. So I'm just going to graph that parent function again. It's that same one we did for the bell work, where we had our -2, 1/9, my -1, 1/3, 0, 1, 1, 3, and 3, 9, which should be 1, 2, 3, 4, 5, 6, 7, 8. Oh, I don't have one on this graph. It got cut off. And that's okay. So this is my parent function. It's that same guy we just did on the previous page. Looks like this. This is my f of x. So all those questions we answered in the bell work too are the same ones we have done here. The domain, the range, and the asymptote. So our domain on this one, that's our -infinity to +infinity. Our range goes from 0 to infinity. And our horizontal asymptote, that line that we cannot cross, that's our y equals 0. So for our parent functions, those are always going to be the same. Every single parent function is going to have those same asymptotes, that same domain, that same range. Every single one. We do have to be careful when we're looking at our transformations, because sometimes those things can change on our transformations. So I'm going to put up here that transformation form we were talking through yesterday when we had our a times our b x minus h plus k. And what we're going to start with is we're going to start by identifying our a, h, and k so that we can apply those transformations. So a is the number that's multiplied in front. So in this case, it's this 2 that's multiplied in front. So my a equals 2. That means I'm going to take my function and it's going to get stretched vertically. If my a is bigger than 1, it stretches. If my a is smaller than 1, it compresses. It looks like somebody sat on it because he's so squishy and cute. Looks like somebody sat on it. And then if my a is negative, that's when we get our reflection over our x-axis. So that's what we mean when we're looking at identifying the transformation, is just putting the words on them. And they have the exact same jobs that they've had since we talked about a, h, and k the first time back in I think in August is when we really hit first the a, h, and k. So we've been working with it for a while. Our k is tucked on the end over here. It's this -4. And what k tells us is our vertical shift. We think of k as a kite or as a kangaroo, where it's pretty much just going up and down. So my k of -4 means this whole thing is going to go ka-chunk, 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 ka-chunk down 4. So it's going to, so that moves our asymptote, that moves our function. Everything's going to go down 4. And then our last piece of our transformation we have to be super duper careful with is this -h, because h is always going to have the opposite sign of the expression in there. So since that is an x plus 1 in the exponent, what my h is actually -1. So this whole thing's going to move left. It's going to move down 4. I have no idea how to reverse this to make sure it's facing the right way for you, because I do not know if I'm showing mirrored or not. So we're going to go left 1, down 4, and we're going to have our vertical stretch. So those are our transformations in words. Let's apply them the same way we kind of did yesterday. I'm going to use a dark blue for my transform function. And that's when I take my x's from my parent function and we're going to add h. So I'm going to take my x's and we're going to add -1. So my x's, we're going to take away 1. For my y's, we go times a and then plus k. So we're going to take our y's, then they're times 2, and then -4. So looking at the pieces we have, taking my x's from over here, so I'm going to have my -2, and then we need to subtract 1. So -2 minus 1 gives us a -3. My -1 minus 1 gives me a -2. 0 minus 1 is -1. 1 minus 1 is 0. And 2 minus 1 is 1. So I'm just applying that same transformation to all my x's. For my y's, especially with these fractions, sometimes we do want to use a calculator. It'll make things a little bit easier. You don't have to. We can do it by hand. It's okay. Because we're going to take our 1/9 and put it through this. So 1/9 times 2, that would give us 2/9. And then -4 will give us -3 7/9, or -3.78-ish. We're close. When we're graphing, we're kind of taking the vibe of the point. We are not necessarily going for perfection. If I want a perfect graph, we will graph them digitally. We're getting it-ish. We're getting as close as we can. We're not going to stress about, well, whether is that 7/9 or is that 8/9 or is that 6/9? Who knows? No. We're going to get it close. We're going to call it good. We're not going to stress. Same vibe going down. So we're going to take our 1/3 times 2. That'll give me 2/3. And then -4. And we'll get -3 1/3. Or -3.3-ish. Then we're back into the world of whole numbers, and we're so much happier with that because we're taking our 1 times our 2, and that's going to give us 2. -4 gives us -2. 3 times 2 gives us 6, -4, and we get a +2. 9 times 2 gives us 18, -4, 14. Definitely not on the graph, but that's okay. We're still filling in our table. Our last thing to pull up before we do our graph is we need to put our asymptote up there. And our asymptote is always going to be at our y equals k. So we're at y equals -4. So my asymptote for my transform function is actually going to be down 1, 2, 3, 4. Here. We draw our asymptotes as dotted lines. I highly recommend using a ruler, because that'll make things easier. But it should look like that. And then when we plot up our points, it's going to be our -3, -3.7, and -2, -3.3, -1, -2, 0, 2, and 114 was way off the chart. So our graph is going to look something like this. Making it a little bit thicker. And then our last piece on this one is to state our domain and range, because we've already got our asymptote. Our domain is the exact same as it is for our parent function. It should be the same for all of them, that we go from negative infinity to positive infinity. On this one, however, it's not that we're going to go from 0 to infinity on the range. Our very smallest is very nearly -4. And this, in fact, will always have a part of our asymptote in it. So our asymptote is going to be a part of this. Our -4, and then our y's are going up. So we're going up to infinity. We're always going to put those intervals as smallest to largest. So they're going to look kind of like this. But that gives you one of the homework questions on that homework that you guys picked up yesterday done, and gives us a little extra practice on the graphing, and lets us do that without having to worry about trying to figure out how to get graphs to you when you're at home. So that was kind of my thought on that one. Let's just practice it. Not making it stressful in the notebook. Questions on this one? Okay. That is everything I've got for you today. You have about 4 minutes left in the period, technically. So use this time to work on stuff. I'm trying to get absolutely everything graded in today. I will get all of your guys' past homeworks passed back to you tomorrow. We're also going to have a lot of time to work through the review and ask questions and stuff. We'll probably do another graph or two together just so we can practice it together. But I probably will not do notes the whole time tomorrow, just since we've seen the transformations. We've talked through some a couple of times. We'll probably do 1 or 2, but that'll be it. And then we'll have time to work on the homework and the review, because we got a test coming up on Friday. All right, so if you need to scoot, feel free to scoot. If you want to stay and hang and ask questions, I'm here. But that's all I got for you today.